ladies and gentlemen, as a convener of this session, I would like to give you an overview presentation on these topics. Contents as follows. First introduction, and the next results on comprehensive research project on earthquake-induced landslides by Japan Landslide Society, and then results of international symposium on earthquake-induced landslides in Japan in 2012. And then finally, as concluding remarks, I mentioned the necessity of future research. Introduction. Strong earthquakes often cause a very large number of landslides in hilly and mountainous areas. During the last decades, a number of reports have been published to show serious damage caused by landslide after a series of disastrous earthquake events in mountainous regions. A lot of researches on earthquake-induced landslides have been intensively carried out by various institutions and researchers. Because of time shortage, I would like to mention only a few review articles. Namely, David Kiefer reported in 2002 investigating landslide caused by earthquakes, historical review. Or Janusz Wazowski reported in 2011 towards the next generation of research on earthquake-induced landslides, current issues, and future challenges. For example, Kiefer has shown this relationship about areas affected by landslides in the earthquakes correlated with earthquake magnitude between affected areas and magnitude. Or also he has shown about the following item: maximum distances from epicenters and fault ruptures were determined for landslides in each major category for each earthquake. It's a very popular diagram. So, on the basis of recent experiences, certain knowledge were already integrated to these topics, and nowadays, earthquake-induced landslides became common targets. In 1999, Chichi earthquake occurred in Taiwan, or 2004 Mid-Niigata Prefecture earthquake in Japan, and 2008, the strong earthquake, Wenchang earthquake occurred in China, and so on. For example, in Japan, 2004, Mid-Niigata Prefecture earthquake caused a large number of earthquakes, as you can see here, and a lot of landslide dams were formed, and emergency operation to avoid collapse of the landslide dam was urgent problem at that time. On the basis of such experiences, we had to pay attention to significance and the necessity to clarify the mechanism of earthquake-induced landslides and to sophisticate the countermeasure design and planning. Several important points: fundamental study of the occurrence field of earthquake-induced landslides necessary, and intensive study on the mechanism of earthquake-induced landslides, and evaluation of danger degree and hazard zonation, and appropriate land use and regional development for the mitigation of disasters caused by earthquake-induced landslides are necessary, and international exchange of knowledge and information are expected. On the basis of experiences, Japan Landslide Society has established a task force in order to carry out research project on earthquake-induced landslides. So these are main contents of this research project, and objective of the project is first to clarify mechanism of earthquake-induced landslides, and finally to make up a technical proposal for disaster mitigation. In order to carry out practical research activities, altogether 8 working groups are arranged, for example, on mechanism, on risk assessment, on secondary disasters, on soft measures, or on hard measures. So these research results should be integrated to guidelines. And review of recent events in Japan has carried out, and review of overseas events, historical analysis of past events are carried out, and these results are integrated into database. So whole research output included in this general report of the project results, and these are main contents of this general report. I would like to show you some examples of the output. For example, Professor Kamai has shown this classification of landslide types caused by Kobe earthquake into 4 types, and he introduced that size of artificial filling shows high percentage. Or Professor Sasa has developed such a dynamic ring shear apparatus in order to clarify the mechanism of the earthquake-induced landslides. This is test results on Nikawa landslide. After the main shock, pore water pressure kept increasing and the shear resistance decreasing, and sliding was accelerated. Other point is analysis of stress and strain of ground layer. This was carried out by Professor Wakai using dynamic FEM analysis. And earthquake response analysis was also carried out to find occurrence fields of earthquake-induced landslides. So target areas are divided into numerous number of calculation grid, and a distribution of maximum horizontal acceleration was calculated. As you can see, high acceleration values are shown near ridge where slope failure occurs. And distribution of maximum shear stress were also calculated, and here you can see high shear stress values near very bottom, corresponding to the location of actual representative landslide occurrence. So, however, there is remaining some problems to be solved. And for example, evaluation of danger degree of individual slopes is necessary, and also formation of design criteria for countermeasures is also important. And probably most important is formulation of risk map on earthquake-induced landslides. This can be carried out in 4 steps, namely first extraction of dangerous slopes, and then classification of landslide types, which is related to evaluation of danger degree, and on this basis formulation of a hazard map, and finally formulation of a risk map with consideration of objectives to be protected. After the research activities, international symposium on this topic was held in Japan in 2012. These are main topics, and I would like to mention about some interesting items on this symposium, for example, concerning movement types, characteristics, and process, and concerning causal mechanism or large displacement and long travel distance of soil mass, or risk assessment and hazard zoning, and secondary hazards. I would like to show some outputs of this symposium. For example, Hideaki and Abe shown this classification of the movement types of earthquake-induced landslides in relation with geomorphology and geology. Here you can see a translational type of landslide, or slump type, or toppling type, which correlated with geomorphologic and geologic structure, respectively. Next interesting point is relationship among movement type, geology, and distance from the epicenter. Here you can see several different types of landslides caused by earthquake, translational, slump, or flow, or fall, or rock avalanche, etc. And here you can see, for example, relationship between translational slide type and sedimentary rocks as a geologic background. And other important point is location of landslides occurrence concerning the inland earthquakes. Most of landslides occur within distance 20 kilometers from epicenter. You can see clearly. So this data is based on events in Japan, and same analysis was carried out also from overseas events. A little bit different results can be seen. And other important aspect is concerning the earthquake-induced landslide. Also, we must pay attention to the secondary phenomena, secondary landslides or enlargement of landslides caused by rainfall or snow melt afterwards. So and such secondary phenomena bring quite often high social impact. Therefore, it is also necessary to pay attention to high social impacts by the secondary phenomena. So, as concluding remarks, I would like to mention the necessity of future researches. First, a relationship between the location of the epicenter was a source fault, and that of the earthquake-induced landslide should be explained more clearly, and physical and mechanical characteristics of unconsolidated sediments should be clarified, and appropriate risk assessment methods and hazard zoning methods should be developed with sufficient accuracy to promote reasonable land use to avoid damage by earthquake-induced landslides. How to design sufficient resistant technical prevention measures, it is still remaining problem. Thank you very much for your attention.